All right, so lesson 38 is on the dot product of vectors and the angle between two vectors. So it's really just going to be a bunch of formulas that I'm giving to you. We're just plugging and chugging. The dot product is like this super simple. It's the best thing about vectors. It's very easy. Okay, so it says vectors can be multiplied in different ways. So it says one way, the cross product is used when 3 dimensions are used, and it creates a vector that's perpendicular to both vectors. So basically, if you have a vector like this, think about the corner of a classroom, like the bottom corner, and something like that, then maybe you have a wall, like a, do you guys know what I'm saying? Like that's the 3 corners of a classroom, like 3 dimensions. So we actually are going to do that. I said, luckily for you, we won't be covering this in pre-calc. Yeah, actually we are. We're going to talk about it a little bit. But the thing we're going to talk about today is something called the dot product, which creates just a number. It's not going to create like another vector like the cross product does. So it seems really useless when you first learn it. You're like, what am I finding? Like, what geometrically am I finding? But it's used in several of these formulas that you're gonna learn about. Okay, so it's very simple. You guys will like this. So it says if u is the vector u1, u2, and v is v1, v2, then u dot v. So that's how we read it, not u times v or u multiplied by v. It's u dot v, which you might see with the little harpoon things above them, or you might see with bold. Remember, you can write bold things as vectors. It ends up being u1 multiplied by v1, oops, I don't know why I did the vector thing there, and then plus u2 multiplied by v2. So super simple. All you do for 1a is you take 4 and you multiply by -1, and then you add that by 5 multiplied by 3. So you get -4 plus 15, which is the number 11. And it's not a vector or anything, it's just a number in the end.
What does it signify? Like what?
That's what I told you. It doesn't make anything geometric, but it's used in formulas that will make sense in a second. So the next one, so if I have 1 times -6 and I add it to -2 times 3, we end up getting -6 plus -6, so our dot product is just -12. Don't you hope that all of the test is this? Wouldn't that be nice? Just make them all dot product.
That would be amazing.
All right, so you might also see them with the IJ notation, your favorite. So if you do, just rewrite it first. So it's 2 comma -3, and we're dot producting it with, what's the next vector? 5 comma 0, because there's no j, right? It's 5i, but no j. So if we do the dot product, we're going to have 2 times 5, and we're going to add it to -3 times 0. So we get 10 plus 0, so our dot product is 10. Okay, so there's lots of uses for the dot product. The thing that we're going to talk about the most, though, is to find the angle between two vectors. So if you have a vector going in this direction and a vector going in this direction, and you wanted to find that angle, then we can do that pretty easily. It's not too bad. So it says if theta is the angle between the non-zero vectors u and v, then cosine of theta ends up being u dot v on top divided by the magnitude of each of them. So the magnitude of u and the magnitude of v. So this is the formula that I would say you need to memorize. It's not hard to memorize. U and v, right? Yeah, that dot is the dot product. All right, books will sometimes write it as inverse cosine of u dot v all over magnitude of u, magnitude of v. Okay, but I just remember it in the cosine form. Okay, so number 1 says find the angle between the two vectors in degrees, round to 3 decimal places if needed. So let's draw a sketch. So if I was drawing a sketch of 2, 4, remember, it's just starting at the origin and going in that direction. And then -1, 3, right? So its standard vector would be starting at the origin and going that way. So we have u and we have v. Okay, so our angle looks like an acute angle. So we're going to find it. So we do this by doing cosine of theta is equal to u dot v all over the magnitude of u and the magnitude of v. So u dot v is going to be 2 times -1 So negative 2 plus 4 times 3 is 12. Do you guys see where I got those numbers? Right? I did the first two components multiplied, last two components multiplied, added. All right, the magnitude of u is going to be 2 squared plus 4 squared. Maybe I'll write that out so you guys can see it. And the magnitude of v is going to be negative 1 squared plus 3 squared. So we get 10 on top. And we have the square root of 20, which we don't need to simplify down. It's fine. And we have the square root of, let's see, 9 plus 1, so 10. So we have that. And you could simplify this one down. I think it actually simplifies down to root 2 over 2. So if you have cosine of theta equals root 2 over 2, what's the angle? 45, right? Does that make sense? All right, so in this case, if you have 10, I would just put it into your calculator. Do 10 divided by. Just make sure that you put parentheses around this. So if you're going to do the square root of 20 and then times, so go and try it along with me, square root of 10, make sure you're putting it in correctly. And then do inverse cosine of that answer. So it's basically like 10 over the square root of 200, basically, which reduces down. So we ended up getting theta is equal to 45 degrees. So that one you could have actually done by hand. But. All right, I'll let you use your calculator on it. All right, so the next one. So same idea. So we have 2i plus j. So I'm going to have 2 comma 1. And I have v is negative 1 comma negative 3. So we set it up the same way. So we have cosine of theta equals the dot product, u dot v. What's the dot product of u dot v? Negative 2 plus negative 3. Can you guys do the dot product in your head? It's not hard. Are you guys understanding what we're doing? These two multiply together, these two multiply together, add your result. So negative 2 plus negative 3. So we get negative 5. And then the magnitude of u and the magnitude of v. Can you guys find those in your head? So you're going to do 2 squared plus 1 squared. So I get 4 plus 1, so 5. And then here we go. So I have negative 1 squared is 1. Negative 3 squared is 9. 1 plus 9 is 10. So you can just put that all into your calculator as it is if you want. I'm fine with that. I think it also works out to be, at this time, a negative root 2 over 2. But if you do inverse cosine of that answer, negative 0.70710, you end up getting 135 degrees. That's what theta is. Okay? Again, I tend to sketch it out just to make sure. So let's sketch out where 2 comma 1 is. So it's right there. And then negative 1 comma negative 3. It's right there. Does it look like 135 degrees? Yeah. It's not like an acute angle, is it? It's an obtuse angle. It looks like 135 degrees. So it's always nice to do a sketch just to kind of confirm that you're correct. All right. So number 2. This is a tough one. I do have one like this on your homework. Okay, so stay with me. This is a long one. Are you paying attention? It's a hard one. If I put it on, I did put it on your homework, but if I put it on your test, it will be a bonus. Don't we like bonuses?
Are we having a test soon? Since this is the
It is. Well, this isn't the end of the chapter, actually. I just hadn't finished the notes for the other one. Because Dave Vesper asked for me to put cross product in, so I was like, oh, I'll do that. That's why at the very beginning of this section, I said, we won't do cross product, and then we actually are doing cross product. So the physics teachers have talked and told me what they want. All right, so find the vectors v satisfying u dot v equals 10, where u, we know what u is. U is the vector 2 comma 3, but we don't know what v is, okay? So v is just going to be some kind of vector, which I'm going to call x comma y, right? We want to find those components. So the first thing we're told is that u dot v equals 10. Okay, so if u dot v is equal to 10, that means 2 times x added to 3 times y has to be 10. Do you guys see how I got that? Multiplied these ones, right? Added them together. That's what that's saying. Okay, so we have one equation that has x and y. Do you think we're going to have another equation that has x and y? We totally are. But it's not going to be a nice linear one like this. All right, so this next thing says that I keep wanting to say modulus, but the magnitude squared is equal to 17. Okay, so the magnitude of v is going to be x squared plus y squared under a square root. So it's saying if we square that, we get 17. So in other words, we have x squared plus y squared is equal to 17. Okay. And you guys totally know how to do this. It's just been a long time. We did this in Algebra 2. It was solving systems of nonlinear equations, right? We've done this. So do you see how you can't just line them up and add straight down and do substitution or elimination? Like it doesn't work. You can't do the elimination method, right? Because you have an x squared and a y squared. All right, so what we're going to do is we're going to solve. So we're doing substitution. So we have this equation and we have this equation. And we're going to solve for either x or y. Okay, so let's say we solve for y. If we get the y by itself in this equation, we're going to have the 10. We're going to subtract the 2x over, and we're going to divide by 3. Can you all do that in your head? Yes. So that means in the second equation, I'm going to replace y with 10 minus 2x over 3, and I'm going to square it. So it gets kind of gross for a little bit. So we're going to FOIL it out. So I'm going to have x squared. When I FOIL 10 minus 2x times itself, you can do it off to the side if you need to, you're going to get 100 minus 40x, right? Minus 20x plus 4x squared all over 9 equals 17. How can we make it a little bit easier on ourselves? Could we multiply through by something? Yeah, let's multiply through by 9. Let's clear the fraction. So when we do that, we get 9x squared plus, and the 9 and 9 will cancel, so we'll still have 100 minus 40x plus 4x squared equals 17 times 9. Anybody know that? Oh, look at you. Good job. So we combine all of our x squared, so we get 13x squared minus 40x. We have 100 and we subtract the 153 over and we get 53. So I don't know if it factors or not. When I'm not sure, what do? Quadratic formula. Yeah, so we're going to do that. See, I'm telling you, it's never any question. This is why it's a really, really good bonus question. All right, so I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And one of them ends up being nice and one of them is not. So that inside part is going to be 1600 minus 4 times 13 times. The inside part is the square root of 4,356, which ends up being 66. How nice. So it would factor, I bet. So when I do 40 plus 66, and then I divide by 26, I get, it looks kind of gross, but it's 53 over 13. And when I do the other one, 40 minus 66 over 26, I get negative 1. How nice. So the last thing you have to do is these are the values for x. So that means we have a vector that starts with 53 over 13, but we don't know what its y value is. And we have a vector that starts with negative 1, but we don't know its y value. So how do I find that y value?
You plug it into.
Yeah, you plug it into any of those equations. So I would pick this equation right here. Do you guys see it? Y equals 10 minus 2x divided by 3. So when you plug it in there, you're going to have negative 2 times that answer. 10. plus the answer. So I'm doing it all on my calculator. You end up getting 8 over 13 for the y. So 53 over 13, comma 8, comma over 13. And when you plug in -1, let's see, you get 10 plus 2 is 12 divided by 3, so you get 4. Those are your two answers. So you have to do all that work, though. Otherwise, I mean, a lot of people might try guess and check, but you're never going to guess 53 over 13, right? You might get the -1, comma 4, but you're not going to get both vectors. All right, I'll let you go on break really quickly. Their head recording? All right, so the next one. Okay, so one more formula. So it says if vectors u and v are perpendicular, then the angle between them is 90 degrees. So the formula that you guys just learned was that cosine of theta is equal to u dot v all over the magnitude of u, magnitude of v. So if the angle between them is 90 degrees, well, what's cosine of 90? Think about your unit circle. What is cosine of 90? It's 0, right? That's the point 0, comma 1. So in other words, we have 0 is equal to u dot v all over the magnitude of u, magnitude of v. Well, the magnitude of u and v, as long as they're not like the 0 vector, meaning there's no like length at all, that's not going to be 0. What's going to make this 0 is the numerator. So it says the vectors u and v are what we call orthogonal or perpendicular. Okay, that's another word for perpendicular, orthogonal. If and only if u dot v is equal to 0. So typically we use the word perpendicular when we talk about 2 dimensions, but if we talk about anything more than 2 dimensions, usually 3 dimensions, then it's going to be orthogonal. Did you know you can have 4 dimensions, 5 dimensions? Ooh, weird. All right. So number 1, so it says prove that u, which is the vector 4, 6, and v, which is the vector -3, 2, are orthogonal. So if you want to show that they are orthogonal, I don't know why I gave you so much room, all you're showing is that their dot product, u dot v, equals 0. That's it. Okay, so show that u dot v is equal to 0. Okay, so we can do that. So u dot v is going to be 4 times -3 plus 6 times 2, right? The x components multiplied, added to the y components multiplied. So we get -12 plus 12. I don't know where you got 4, which is 0. So yes, those two vectors would be orthogonal or perpendicular. And if you sketch it out, it totally makes sense because you have 4, comma 6. Let's look at the picture. That's u. And then v is -3, comma 2. It's here. Doesn't it look like a 90-degree angle between them? Yeah. So if you want to kind of confirm by a sketch, you could always do that. It looks like 90 degrees.
Orthogonal or like perpendicular?
Perpendicular. Same word.
Same.
Yeah, they're the same. They've never heard orthogonal either. They don't know what that means. All right, we use the word orthogonal because like I was talking about with 3 dimensions, like you could have something like that. These would be 3 orthogonal vectors, right? So, weird word, I know. All right, so find a vector that would be orthogonal to -4, comma 13. Are there others? So basically we're saying -4, comma 13. If I do the dot product with some vector, x, y, I want to get 0.
That's not possible.
So -4 times x plus 13y has to equal 0. It could totally be possible.
What?
So what's one example? Can anybody come up with one?
4x minus 13.
No.
13, -4.
Yeah. 13 and -4. That works. Do you guys see it? Because you'd have -4 times 13 is -52. 13 times -4. Wait, hang on. Is it negative? So it'd have to be +4. Is that right? +4. See, -4 times 13 plus 13 times 4. Does that make 0? Sure. All right. Are there others? What if I started it with 26? Yeah, what would I need for y? 8. Right? What if I had -13? -4. There's an infinite number of them. Yes?
Did you do 0, 0?
You could do 0, 0, but I would usually say like a non-zero vector. Like it's not really orthogonal. It's just like the vector 0, 0 is it's like has no length to it. So it's like a point kind of. Does it make sense? It is a point. All right. So yeah, we don't typically say 0, 0. All right. So question: what do you think theta must be for two vectors for them to be parallel to each other? 1. You guys think? Theta must be 1? I don't know. So in order for them to be parallel, that means that our vector, they have to go off in the same direction, right? But remember, vectors, you can move them. You just basically move one on top of the other. Oh, I thought that was going to actually move. It didn't.
0.
Yeah, so the angle between them would actually be 0. Does that make sense? What if I had something like this? Are those parallel vectors?
Yes.
Yeah, they're parallel. And if I put it on top of the other one, what's the angle between them? If I put it that way.
180.
Ah, yeah, 180, good. So the angle would have to be 0 or 180 degrees in order for that to happen. So if the book asks for, are these two things parallel, then you're just basically doing the cosine theta formula, and you're seeing if theta equals 0 or if it equals 180, okay? So you're going through all that. Oops, that was loud. All right. Was that it? I think that's it. All right.